Conservation of angular momentum. Angular momentum of an isolated system remains constant in both magnitude and direction. The angular momentum is defined as the product of the moment of inertia and its angular velocity. Angular momentum is a vector quantity, and the vector sum of angular momenta of all the parts of an isolated system will always remain constant. This puts a strong constraint on the types of rotational motions which can occur in an isolated system. If one part of the system is given an angular momentum in a given direction, then some other part or parts of the system must simultaneously be given exactly the same angular momentum, but in opposite direction. Conservation of angular momentum is an absolute symmetry of nature. So now let's do a problem. A turntable consisting of a disk of mass 125 grams and radius 7.2 centimeters is spinning with an angular speed of 0.48 revolutions per second about a vertical axis. An identical initially non-rotating disk is suddenly dropped onto the first. The friction between the two disks causes them to eventually rotate at the same speed. The third identical non-rotating disk is then dropped onto the combination, and eventually all three rotate together. What is the angular speed of this combination? So this question says that we have a rotating turntable, right? And it's rotating with some omega I, some velocity that's there. It has a certain mass m, which is 125 grams. And it has a certain radius, which is given by 7.2 centimeters, right? And it is rotating. And then it says that there are two masses that are dropped on top of here. And it wants us to find omega final. What is omega final? Okay? And they also say that it is identical to the masses, right? So let us assume that this is the z-axis, and it's rotating around the z-axis, and it is a completely, so assumptions, this is a complete inelastic collision. Okay, that means that this objects will come and stick to it. There will be no bouncing or anything. There will be no net vertical external torque. Okay? So, which implies that the angular momentum component along the z-axis is a constant. Okay? So there will be no angular momentum, which is along the vertical component, it won't change. Okay? We will also consider no friction, right? So no friction. It is no friction. It is an idealized case. In this case, the angular momentum is conserved. So delta angular momentum equals 0. That means an initial, so I'm just going to call this angular momentum final minus angular momentum initial, which means it should equal angular momentum initial. Okay? That is my conservation of angular momentum. Now, what do I know about angular momentum? I know that angular momentum is given by I omega, right? That means my angular momentum is going to be I final, omega final equals I initial, omega initial, right? Sounds good to me. Now, what is my I initial? Well, I initial only has one disk, right? So my I initial has one disk, and my final, after my all of these disks have been true, so I final will have 3 disks. Okay, since they are identical, can I call IF as 3 initial? And the answer is yes, I can. So I'm going to plug this value in here. So this will make it 3 initial omega I equals omega I omega F. This goes away. And I will have omega F equals 3 times omega I. Okay? Now, what was the question asking me? The question was asking me, what is my omega F? I know that they gave me omega, they gave me M, and they gave me R, and they gave me the angular speed at which it's rotating, which was given by, I believe this is true, 48 revolutions per second, right? So I can plug that one into here, multiply it, and get my answer. Uh-oh. I made a mistake. Sorry, I made a mistake. This should be final, and this should be initial. While writing it out, I made this mistake. So this is going to be omega final, and this is going to be omega initial. So in order for me to find omega final, I have to do omega initial divided by 3, right? And that will make sense because when I put these on top of these, it will slow down, right? So it'll be 1/3 of whatever this was. And that 3 is coming because it now has 3 disks. Okay, so be very careful. Don't make those mistakes.